Alright, good day and welcome to learning exercise 11,48. In this unit we're looking at independent events. Events are seen as independent. One event does not affect or change the outcome of a second event. Independence can be determined using the following equation. Probability of A taking or probability of B taking into account that A has happened must equal the probability of A. So probability A or probability B taking into account A has happened is conditional probability of A given B. Probability A is simply referred to as marginal probability of A. So we look at the contingency table. School learners, we have types of eyes. So yes, you're a school learner, or no, you're a school learner. So we have brown eyes and not brown eyes. So we have 176 brown eyes that are school learners, 44 that are not school learners, but all in all we have 220 learners that have brown eyes. If you look at not brown eyes, we have 64 that have brown eye or not brown eyes but are school learners, and we have 16 that do not have brown eyes, that's also not school learners. So 80 that do not have brown eyes. In total our sample space equal 300. So determine whether being a school learner and a type of eyes are independent from each other. So, probability school learner, provided take brown eyes into account. So, probability of school learner is 176 over 300. Remember, school learner, alright, with brown eyes, 176 divided by 300, divided by 220. So that's the amount of brown eyes, right, whether school learner or not. 220 divided by 300, it becomes 176 over 300 times 300 over 220. 300 cancels, I'm left with 176 over 220, which equals 0,8. Look at the probability that you're a school learner. So all in all school learners, I have 240 school learners out of 300. We do that probability school learner, 240 divided by 300 equals 0,8. Therefore, being a school learner and having brown eyes are independent. So, probability school learner given brown eyes equal probability school learner. They both equal 0,8. Therefore, they are independent. So, knowledge of one event does not affect the probability of the other event. Hope you follow, hope you understand. Right? Can also apply the product rule. So this one is used more often for independent events, especially grade 11 and grade 12. So probability of A intersection B, or probability A and B, must equal probability A times probability B. So look at the example. Probability A equals 0,5, probability B is 0,4, and we say A and B are independent. Find the probability of A and B. So, probability A and B must equal probability A times probability B. So, I say 0,5 times 0,4, which gives me 0,2. Right? So, that's the one way to find A and B. Now, if you say probability A equals 0,6, probability B equals 0,3, and probability A and B equals 0,6, are A and B independent? So, probability A and B equal probability A times probability B. So that is given as 0,6. 0,6 times 0,3, if I multiply, 0,16 does not equal 0,18. Therefore, A and B are not independent. They are referred to as dependent events. Hope you follow, hope you understand. All the best. Continue giving 120%. Eventually your return will be 1,000%. All the best. Goodbye.